Hey students, this is Miss Denton. This is a short little video with an introduction on how to solve exponential and logarithmic equations. We've graphed them, we know what they look like, but now let's talk about how to solve them. First of all, something really important to know is that logarithms and exponents are inverses of each other. That part is so important. That means they cancel each other out when you solve. So just like adding cancels out subtracting, just like multiplying cancels out dividing, a logarithm can cancel out an exponent, which is really handy if we're trying to get x all by itself when x is an exponent. So check out this little example that's been put together. We've got 3 to the power of what equals 2,187. Well, instead of plugging different numbers in for x to figure it out, we can solve. That means we'd have to get rid of 3. Now, the only way to get rid of 3 is to use a logarithm of the same base. A logarithm base 3 will cancel out an exponent's base 3. Now, as usual, whatever we do to one side of an equation has to be balanced out on the other side of the equation. So notice log base 3 has been inserted to both sides of the equations. And finally, if the 3's cancel out, x is by itself, this is a calculator job. We're going to type this one into our calculator. So I'm going to turn my calculator on here and show you how to insert that. Add a calculator, a nice fresh page. And here we've got the log button over by the 1. You have to hit Control to get the log. Then it's already got a nice base position. I want 3 down there. And then in the parentheses, I need the number 2,187. And my calculator will do the work for me. Okay, that can also be done in the opposite order. Okay, so if the equation is log base 2 of x equals 5 and you need to get x by itself, that means you need to get rid of log base 2. Well, to get rid of a log base 2, we need to raise it as an exponent on the same base. So a log base 2 and an exponent's base 2 will cancel each other out. We need that base 2 on both sides of the equation. We can type this into our calculator instead of doing that in our head. That is 2 to the power of 5. That's not 2 times 5. It's 2 to the power of 5. So here's my power button. That's 32. That's because that's 2 times 2 times 2 times 2 times 2. That's what 2 to the power of 5 is, as you know. Okay, so I'm going to run through some examples, then I'm going to stop the video and give you a chance to practice, okay? All right, my note here with stars. As with any equation solving, we're going to solve backwards through the order of operations. So we're going to get rid of any adding and subtracting first, then any multiplying and dividing, then anything that has to do with exponents and ding, ding, ding. That's where we are in the process with this log and exponential, and then any leftover parentheses. So check out example number 1. I need to get b all by itself, so I need to get rid of base 4. To get rid of a base, I need to use a log of the same base to cancel it out. So a log base 4 and an exponent base 4 will cancel each other out. Just make sure that whatever you put on one side of the equation, you're balancing out on the other side of the equation. And now this is a job for your calculator. Log base 4 of 4,096. So what you're asking your calculator to do is tell you what is the exponent on a 4 that would give me 4,096. Log base 4 of 4,096. That's 6. You can test it. What is 4 to the power of 6? 4,096. So b is all by itself. We ran this through our calculator and we got 6. Okay, let's try this next one. Notice here we have a 3 out front that's not part of the exponential piece of the function. That 3 is a multiplier. We need to get rid of it before we deal with the exponential part. So to get rid of a multiply by 3, I need to divide by 3. That will leave me with 4 to the power of x plus 1 equals 27 divided by 3 is 9. Now, I need to get x, which means I need to get rid of the base 4. I'm working in the exponential part. We just saw how to get rid of a base 4 on example number 1. To get rid of a base 4, I need to use a logarithm of the same base. So a log base 4 will get rid of an exponential base 4. And that'll leave me x plus 1 all by itself. Now, whatever I insert on one side of the equation, I have to match on the other side of the equation. So log base 4 of 9. What you're asking your calculator to do is tell you the exponent on a 4 that would equal 9. I'm pretty sure we're going to get a decimal here. Log base 4 of 9 is quite an irrational decimal, 1.58496. I've almost got x by itself. Now I need to subtract this 1 because the inverse of adding is subtracting. So x equals 1.58496 minus 1 is going to be 0.58496. Okay, so here's our new piece today, guys. To get rid of a base 4, we need to insert a log base 4 to both sides of the equation, even if the equation is more advanced. Okay. All right, one more example to go. This is the exponential piece to this equation, base 16 to the power of 4 minus x. I need to get rid of the other stuff before I deal with the exponential. So work in backwards order. Get rid of any adding and subtracting first. I have a subtract 6. I need to get rid of that by adding. That would leave me with 3 times the exponential part equals 18 plus 6 is 24. Next, I need to get rid of the multiplying and dividing. This is a 3 that's multiplying the exponential, so I need to divide it off. That would leave me with 16 to the power of 4 minus x, and 24 divided by 3 is 8. Now we're to the new part. We need to get rid of the exponential base. We need to get rid of a base 16. Well, move back to example 1 and 2. To get rid of a base 4, we use a log base 4. Up here on our upper notes, to get rid of a base 3, we used a log base 3. So it only makes sense on this problem. To get rid of a base 16, I need a log of a base 16. A log base and an exponential base will always cancel each other out. Whatever you insert to one side of the equation, you've got to put on the other side of the equation to balance it out. Now these are equation solving techniques you already know. Look up here above. Adding 6 on the left, balanced on the right. Dividing by 3 on the left is balanced on the right. Log base 16 on the left is now balanced on the right. And grab my calculator to do that calculation. Log base 16 of 8. 0.75. Log base 16 of 8 is 0.75. Now I just got to finish it out. I've got to get rid of this 4 and get rid of this -1. I want to subtract away the 4 first. You can continue to use your calculator if you need to. 0.75 minus 4, just say minus 4, it'll use the answer you just got. So that's -3.25. Sorry, that's my alarm. -3.25. So I've got negative x equals -3.25. So that means positive x is going to equal positive 3.25. And that's my husband calling me. Okay, that's going to finish up this set of notes. Now what I want you to do is flip this page over and get some practice of your own. Problems 1 through 6 on the back here are great practice. Ask for help. Use your notes. Good luck.